0 to 60 in 6 seconds. That's how quickly a Ferrari can get going. It starts from rest, 0 miles per hour, and then speeds up to 60 miles per hour in 6 seconds. What is this speeding up all about? Physicists call speeding up, that is, increasing speed or velocity, acceleration. As speed and velocity measure change in position per unit time, acceleration measures change in velocity per unit time. The equation for acceleration looks like this. Delta velocity over delta time, or A equals delta V over delta T. Thus, acceleration is also a rate with respect to time. So what about that Ferrari? Let's calculate its acceleration. It starts at rest, 0 miles per hour, and ends up moving at 60 miles per hour. Let's put this into more familiar units. Well, at least in terms of physics. 0 miles per hour, of course, is 0 meters per second. And as it turns out, 60 miles per hour is about 27 meters per second. All this change in velocity has to occur in only 6 seconds. Let's assume that this acceleration is uniform, which means that the car speeds up at a constant rate. This means that the instantaneous acceleration at any time during the 6 seconds is the same as the average acceleration because the acceleration does not change. So let's start calculating. The final velocity, 27 meters per second, minus the initial velocity, 0 meters per second, is the change in velocity, 27 meters per second. So let's calculate acceleration. 27 meters per second divided by the change in time, 6 seconds, is equal to about 4.5 meters per second. Notice this unit. This is the velocity unit, meters per second, over another unit of time, second. Going from 0 to 60 in 6 seconds sounds like a lot of work, and it is. Newton's first law states that an object that experiences no external pushes or pulls remains at rest or travels at constant velocity in a straight line. This means that its acceleration is 0 meters per second at all times. Newton's second law says that a force, a push or a pull, is required to accelerate an object. Force is like the effort you put into moving something. Something in the Ferrari has to create this force in order to make it accelerate. We are all experiencing a force enacted by the Earth, gravity. Gravity, too, creates an acceleration. But when you're standing on the surface of the Earth prevents this acceleration from occurring by exerting another force on you. However, if you're floating up in the clouds, you will experience this acceleration. The acceleration of gravity is 9.8 meters per second. This is about a third as fast as the acceleration of a Ferrari. What then happens when an object stops? When an object slows down or stops, it experiences deceleration, which is negative acceleration, or slowing down. When an object hits the ground, it slows down very quickly. So the delta t in the denominator of the equation, A equals delta V over delta t, this delta t is very small. This means that the acceleration, in this case the deceleration, is very large. This large deceleration requires a lot of force from the ground, which is why falling down hurts. Just to review, acceleration is the change in velocity divided by the change in time. Negative acceleration, or slowing down, is called deceleration. Catch you later.